All right, honors geometry. So you're witnessing raw footage of me trying to figure out these hard quadrilateral proofs, level 2. I'm going to do 3 of them, 3 separate videos. And again, you can watch my thought process as I do this, okay? So I'm given a parallelogram ABCD. That's the big figure, right? The big figure, all right? And I know that ED bisects ADC, this corner angle. And I know that FB bisects ABC, this corner angle. And my goal is to prove that the inside figure is a parallelogram. So I know the ways to prove a parallelogram are to show that both pairs of opposite sides are parallel. So I need to show that DF is parallel to EB, and I need to show that DE is parallel to FB. Well, I have one of those already, okay? Because, DF and EB are part of DC and AB. So because this is a parallelogram, I already know that these opposite sides are parallel. So I'll be interested to see how they let me write that in. So now my job is just, can I prove that these sides are parallel? Okay. And I'm thinking that I'm going to use these angles being bisected to help me do that. Maybe get some, I don't know, alternate interior angles or something like that. I don't know. We'll see. All right. Not quite sure, but we'll have fun figuring it out. All right. So let's take a look at what I can do with the parallel lines, right? So I'm going to try to say that DF is parallel to EB. Just get it out of the way. And we're going to say opposite sides of parallelogram are parallel. So no. So again, we got to kind of go this route of the bigger one. So DC and AB. Okay, good. So now let me see if I can go with DF being parallel to EB. And just say they're smaller sides. If segments that are collinear with parallel segments are, so this one. So segments that are collinear, so it's saying segments that are on parallel lines are parallel. Okay, so I've done that. So I have those two sides parallel. Okay, now my job is to prove these. So let's explore the given a little bit more. So if ED bisects ADC, so ED bisects ADC, then I know that these two angles are congruent. So let's use that, okay? So I know that angle, let's go, ADE is congruent to angle EDC. And that's by an angle bisector. Okay, let's go with the other one too. So, let me draw it down first. So FB over here bisects ABC, this angle. So these two angles are also congruent. Okay. All right, so let's do that here. And I'm letting you know, I think I just figured out the proof, but we'll see. Okay, so I said EBF is congruent to CBF, again by an angle bisector. Nice. Okay. All right. So I have that stuff written out right there. Okay. So now, is there a way to prove that these lines are parallel? Man, oh man. So I'm thinking. So right now, here's what I'm thinking. I know that the big angle D and the big angle B are congruent. I know that. All right. And that's what I thought was going to help me. But I don't know if it's going to right now. Let me take a pause and take a look at it, and then I'll come back. Okay, so I think I got it. So again, I'm going to go back to this idea that the opposite angles are congruent. So I'm going to state that. So angles being congruent. So angle ADC, this is the big parallelogram, and angle CBA. They're congruent because you have opposite angles of a parallelogram are congruent. Okay, so now if those angles are congruent and they're each bisected, then each of the halves must be congruent to each other. So I think there's going to be some reason that goes along with that. With angle, we'll call it angle EDF inside, and angle FBE inside. So angle EDF and angle FBE. They must be congruent. And again, let's take a look at our reasons. If two angles of no. Angles that are each half of the measure of congruent angles are congruent. So that's this idea, right? Because each of them is half the bigger angle. You must first prove the measure of a certain angle or half. Okay, so I have to say that each of them is half. I thought it was self-explanatory. Okay, so EDF is half of angle. So EDF, right. So angle EDF is half of angle ADC. Yep, so when an angle is bisected, each part is half, okay? Same thing down here with FBE. So FBE is going to be half of CBA. Same reason, bisected half. So now I can say that EDF and FBE are congruent. So angle EDF and angle FBE are congruent because they are each half of congruent angles. Angles that are each half the measure of congruent angles are congruent. Okay, great. So I have these two angles congruent. So how is that going to help me? Well, I think I can use those parallel lines inside, right? So I can use this parallel line and this parallel line, and maybe this transversal, right? And say that, this angle and this angle, this angle and this angle are supplementary, okay? And then these two angles would also have to be supplementary, because if they're congruent, an angle supplementary to one of the congruent angles is supplementary to the other, and that would then force these lines to be parallel because they'd be supplementary. So I wonder if I have to say that. I think I will. So I'll say it right now. So I'm going to say angles are supplementary. I'm going to say angle, this one up here, EDF is supplementary with angle DEB. That's because I have parallel lines and I have same side interior angles. Guys, so those two angles. Now I'm going to say that DEB and FBE, this angle must also be supplementary. And I think it's because if an angle is supplementary to one congruent angle, then it's supplementary to the other angle. Okay? So let's see. What do I got? So it says the two angles, no linear pairs, no right angles, two acute angles of right. No, never mind. Huh. I thought I could maybe show that. Let me take a pause. Oh, it's just going to be by substitution. Duh. Substitution. I'm just replacing EDF. So I'm going to actually write it like this. FBE and DEB. Just so I truly show that I'm substituting them out. Done. And now these two same side interior angles are supplementary. Therefore, lines DE and FB must be parallel. If you have same side interior angle supplementary, then the lines are parallel. And thus I have shown that both pairs of opposite sides are parallel. This thing is a parallelogram. So they want DFBE to be a parallelogram. Classify a quadrilateral DFEB, DFBE. DFBE is a parallelogram because I have two pairs of opposite sides parallel. Oh yeah, green check mark. Get this off there. And I am done. Now I did it in how many steps? 13. So did they. Let's see what they did, right? So they did opposite angles, opposite angles, opposite angles. So they use congruent triangles. They said those sides are congruent. Oh my goodness. So they did it a whole different way, right? I am very much focused on showing that in a parallelogram, both pairs of opposite sides are parallel. They chose to do both pairs of opposite sides congruent. That's fine. All right, fun times. There's one. Got 2 more to do. Oof.